Hi guys, hello everyone, this is Saurav here and welcome to today's session on the Vedantu VOS channel. In this session we are going to discuss the migrations to electron deficient carbon. If you recall, we have been discussing such organic chemistry rearrangement reactions or migrations, nucleophilic migrations, and we have already completed migrations to electron deficient oxygen, migration to electron deficient nitrogen, and today we are going to discuss the migrations to electron deficient carbon. इसमें काफी सारे रिएक्शंस आपने पहले पढ़ रखे हैं and my job would be to just refresh few of them and to tell you certain small corner cases. So let's start today's session without much delay. And आज के सेशन में सबसे पहला पार्ट जो हम पढ़ने वाले हैं which is known as the WAGNER-MEERWIN rearrangement. WAGNER-MEERWIन rearrangement को आप normal carbocation rearrangement से भी आप जानते हो and this is being investigated to a very large extent. In fact, the very first time WAGNER-MEERWIN rearrangement was being investigated was for a compound isoborneol, and when it was being treated with H2SO4, it turns into camphene. So to propose the mechanism for this conversion, WAGNER-MEERWIN rearrangement was used. So इसमें ये पता किया गया था कि जब ये when this compound reacts with H2SO4, a carbocation is generated and the carbocation rearranges. Why does a rearrangement take place? A rearrangement happens in a carbocation to acquire more stability. And getting more stable makes it better. If you assume that there is a class and you have an examination where teacher comes and tells you that, okay, fine, we'll be taking a surprise test and you all request the teacher for a small window period for quick revision. If you do that quick revision, probably your marks will be a little higher compared to a situation where you have not done revision. So exactly the same thing happens with a molecule. In such cases, molecule tries to have that small window period or molecule receives a small window period where it can undergo rearrangement to become a little more stable. So ये mechanism होता कैसे है? So let's first draw isoborneol. So isoborneol is drawn like this, and you have two methyl groups over here, and you have a methyl group over here as well. अब यहाँ पे एक OH group है, एक hydrogen है. So this reacts with it reacts with H plus, which comes from H2SO4. In doing so, it turns itself into a carbocation. We can draw it like this. Actually, oxygen picks up that proton. ये oxygen ने ये proton ले लिया, and it turns into OH2. This loses H2O and it turns itself into this compound. ओके, अब इसके पास दो ऑप्शन बचते हैं. या तो ये मिथाइल यहां से मूव करके यहां आ जाए, ओके, आइदर दिस, but this pathway is not favored, as positive charge would come on bridgehead position. So in fact होता क्या है कि something like this happens, and this is a little different from the other rearrangements that you might have seen until now. So there is a positive charge और यहाँ पे एक methyl group है. So this कार्बन कार्बन सिग्मा बॉन्ड, ये जो आपको दिख रहा है, ये कार्बन कार्बन सिग्मा बॉन्ड इन दो कार्बन एटम्स के बीच, यहां के इलेक्ट्रॉन्स यहां मूव करते हैं. ओके, एंड आफ्टर डूइंग सो you get this species. You get this. And then this methyl loses a H plus and you get your camphene molecule. This comes over here and you end up getting this camphene molecule. Okay, so देखिए 1 2 3 4 5. There is a 5-membered ring over here, on 5-membered ring on this side as well. ये पूरा का पूरा 6-membered ring है. So exactly वही स्ट्रक्चर आपको मिल जाता है जो यहाँ पे हमने ड्रॉ करके रखा है. Okay. This becomes the bridge. ये जो पार्ट आप देख रहे हो, this part becomes the bridge. और इधर में एक 5-membered ring, इधर में एक 5-membered ring. This is very interesting क्योंकि इससे पहले ये मैकेनिज्म प्रपोज नहीं किया गया था. Okay, so this is known as a WAGNER-MEERWIN rearrangement. इसको आप नॉर्मल कार्बोकैटायन रीअरेंजमेंट से भी आप जानते हो. एंड WAGNER-MEERWIN रीअरेंजमेंट को समझना काफी डिफिकल्ट नहीं है. WAGNER-MEERWIN रीअरेंजमेंट में आपको कुछ एक चीजें आपको ध्यान रखनी होंगी कि इसमें माइग्रेशन जो होता है वो 3 तरह के होते हैं. ओके, सो लेट्स डिस्कस दिस. सो माइग्रेशन इज आर ऑफ 3 टाइप्स. 3 तरह के माइग्रेशन हो सकते हैं. सो इलेक्ट्रॉन्स which migrate to positively charged carbon can be obtained from 3 locations. एक तो alkyl ग्रुप से मिल जाए आपको, एक आपको यहां से भी मिल सकता है, एराइल ग्रुप से मिल सकता है, या फिर हाइड्राइड से मिल सकता है. एक और मिलता है which we just saw, which is from the C-C bond. So electron which migrate to can be obtained from the alkyl group migration, aryl halide or hydride migration, or carbon-carbon bond migration. Let's look at certain cases. कुछ एक cases आपको पता नहीं है, so it will be easier for you to understand. So let's start with alkyl group migration. बहुत सिंपल सा एक प्रोसेस है जिसको हम बोलते हैं acid catalyzed dehydration of alcohol. So suppose you have a compound like this, CH2OH, इसको बोलते हैं neopentyl alcohol. This is being treated with H plus, in fact concentrated H2SO4. What you will get is MECME, ME, and there will be CH2 with positive charge क्योंकि यहाँ पे water निकल जाता है. Now once this is created, one of these 3 methyl groups will migrate. ये यहाँ पे move करके आ जाएगा, and we will be getting CH3, C, CH3 with a positive charge, CH2, Me. Why is this migration occurring? Because this carbocation had 0 hyperconjugative structures, while this one which is created has 3 plus 3 6 2 8 hyperconjugative structures. Now this will lose another proton from here, and we will be getting a compound like this. So ये आपका एल्कीन बनके रेडी हो जाता है. This is dehydration of an alcohol. इसमें alkyl migration हुआ है. Okay, you have observed migration of an alkyl. एक दूसरा रिएक्शन हम ले सकते हैं इस तरह का। हमेशा याद रखिए कि ये सारे रिएक्शन किसी न किसी फॉर्म में एग्जामिनेशन में पूछ दिए जाएंगे। ओके, सो इट इज इंपॉर्टेंट टू नो द टेम्पलेट्स, सो दिस बिकम्स अ टेम्पलेट, इसके ऊपर आप बहुत कुछ बिल्ड कर सकते हो। सो इफ यू हैव समथिंग लाइक दिस, साइक्लोहेक्साइल यूनिट है यहाँ पे, एंड देयर इज अ मिथाइल ग्रुप, और यहां पे मैंने एक NH2 लगा के रखा है। इसको अगर आप नाइट्रस एसिड के साथ ट्रीट करते हो, ओके, इसको आप अगर नाइट्रस एसिड के साथ ट्रीट करते हो, देन it turns into an alkyl diazonium salt. Okay, it turns into an alkyl diazonium salt. N2 plus. Alkyl diazonium salts stable नहीं होते हैं for the simple reason that alkyl diazonium salts में conjugation नहीं हो पाता है. So this breaks, और ये ब्रेक करके नाइट्रोजन बाहर निकल गया, and you will be getting a carbocation. अब ये मिथाइल यहां से माइग्रेट करता है यहां पे, एंड इसको हम बोलते हैं 1,2 Me माइनस शिफ्ट, एंड वी गेट दिस स्पीशीज। ये मीडियम में पड़े हुए H2O के साथ रिएक्शन करके एक H प्लस लूज करता है, एंड वी एंड अप गेटिंग एन अल्कोहल विच लुक्स लाइक दिस। एक 3 डिग्री अल्कोहल आपको मिलता है। ओके, यू गेट अ 3 डिग्री अल्कोहल। दो तरह के मैंने आपको रिएक्शन दिखाया। कुछ और रिएक्शन देखते हैं। सो there is a mechanism through which we isomerize alkyl halides. Okay, आइसोमराइजेशन में भी कभी कभार ये यूज होता है, जैसे कुछ, नॉट ऑल आइसोमराइजेशन रिएक्शन, some specific isomerization reactions. For example, if you take CH2Cl और इसको अगर आपने SbCl5 के साथ ट्रीट किया, एंटीमनी पेंटाक्लोराइड। So when you treat this with antimony pentachloride, होता क्या है कि antimony pentachloride being a Lewis acid reacts with chlorine, CH2Cl SbCl5 माइनस प्लस। अब ये क्लोरीन के ऊपर जैसे प्लस आता है, यहां से बॉन्ड टूटता है, एंड वी गेट Me एंड CH2 उसके ऊपर पॉजिटिव चार्ज। ओके, अब यहां पे क्या होगा, ये मिथाइल ग्रुप देख रहे हो, नियोपेंटाइल में भी पहले यहां ऐसे में ये भी, ये नियोपेंटाइल क्लोराइड है, पहला नियोपेंटाइल अल्कोहल था। सो दिस विल मूव ओवर हियर, एंड इफ इट मूव्स, व्हाट विल happen is creation of this carbocation. Once this carbocation is created, then SbCl6 में से एक क्लोरीन इसके साथ रिएक्शन करता है, SbCl5 बाहर निकल जाता है, एंड वी गेट क्लोरीन टू बी प्रेजेंट एट अ डिफरेंट पोजीशन देन बिफोर। पहले यहां पे कहीं प्रेजेंट था, अब इस मॉलिक्यूल का ये आइसोमर बन चुका है। ओके, पहले 3 कार्बन का प्रिंसिपल चेन था, नाउ वी हैव अ प्रिंसिपल चेन ऑफ 4 कार्बन एटम्स। सो वी हैव ऑब्जर्व्ड एन आइसोमराइजेशन रिएक्शन टू हैव ऑकर्ड। ओके, नेक्स्ट एक रिएक्शन लेते हैं। अगर हमने एक एल्कीन लिया, ये आइसोमराइजेशन रिएक्शन एल्कीन्स में भी ऑब्जर्व होता है। चलो देखते हैं। Me इसको आपने H प्लस के साथ ट्रीट किया, ओके, जो कि H2SO4 से आ रहा है, देन व्हाट विल हैपन इज अ कार्बोकैटायन विल बी फॉर्म्ड विच विल बी अ स्टेबल वन। ठीक है, ठीक है, एक कार्बोकैटायन बन के आएगा बट दिस इज नॉट क्वाइट स्टेबल, ये 2 डिग्री कार्बोकैटायन। अब यहां से एक मिथाइल यहां मूव करके आता है एंड वी गेट अ 3 degree carbocation and this will lose a H plus and it will create MEME। तो आप देख रहे हैं इस कंपाउंड का ये आइसोमर बन चुका है, पोजीशन भी चेंज हो गई मिथाइल की एंड डबल बॉन्ड की भी पोजीशन चेंज हो चुकी है। ओके, सो ये हो गया माइग्रेशन ऑफ एल्काइल ग्रुप। अगर हम माइग्रेशन ऑफ सिग्मा बॉन्ड देखें तो पहला तो हमने देख लिया है, आइसोबोर्नियोल टू कैम्फीन का एग्जांपल तो हमने ऑलरेडी ऑब्जर्व कर लिया है। सो दिस वाज द केस ऑफ आइसोबोर्नियोल to caffeine sorry, double bond cannot be connected to Me, it has to be CH2। इन छोटी छोटी चीजों का ध्यान रखिएगा। Me this। So आइसोबोर्नियोल टू कैम्फीन हमने ऑलरेडी ऑब्जर्व कर लिया। एक दूसरा रिएक्शन देखते हैं। मान लो कि आपके पास कुछ इस तरह का कंपाउंड है। याद रखिए ऑल ऑफ दीज क्वेश्चंस हैव बीन आस्क्ड इन पास्ट इन JEE, INCHO, ICHO, किसी न किसी फॉर्म में ये पूछा जा चुका है। So if I treat it with H plus, what will happen is will create a carbocation okay, and then this carbon carbon bond will break and it will migrate. It will do that so as to release the strain. 4-membered ring has more strain, 5-membered ring has less strain. So it will create something like this. Positive charge will come on one of the carbon atoms of the bridge head position and now lose a proton. It will become something like this. Please do remember that whenever you are removing a proton to create an alkene, the most stable alkene will be observed. Okay, or you will create the most stable alkene. Try not to create a less stable or a non-stable alkene that will be too much, that will be very difficult. Okay, that happens only under specific conditions. Let's look at another case of migration of CC sigma bond. So you have a compound like this. CH2I. Okay, and this is now being treated with AgNO3. Now AgNO3 करता क्या है कि AgNO3 is like a thief. It will try to remove a halogen wherever it is attached. So it is going to bind itself to iodine and it will remove it as AgI, which will create a carbocation at the carbon atom which is CH2. And we will get something like this, CH2 plus. अब यहां से ये सिग्मा बॉन्ड इधर माइग्रेट करती है एंड वी एंड अप गेटिंग अ स्पीशीज लाइक दिस। याद रखो कि इसको करने से एक ब्रिज हेड पोजीशन पे कार्बोकैटायन क्रिएट होता है। प्लीज रिमेंबर इन लार्जर रिंग्स, सो यू हैव 3 plus 2 plus 2 plus 2, so very large ring. ऐसे large rings में the number bridgehead position can have a positive charge. Smaller rings it is impossible. So therefore यहाँ पे जब इसको H2O के साथ आप रिएक्शन कराओगे, so it will create something like this. Okay, it will create something like this. I hope this is understood. Okay, chaliye. The next reaction is known as the PINACOL rearrangement. PINACOL rearrangement is one of the most important reactions for JEE. इसके ऊपर every alternate year में एक ना एक question आ जाता है. PINACOL rearrangement काफी easy है. इसमें हम करते क्या है कि what we do is we take a vicinal diol, and vicinal diol is treated with H2SO4, which creates a carbonyl compound through a carbocation rearrangement. Okay, or through, you can think of a rearrangement to an electron deficient carbon, and it is known as pinacolone. Okay, now how does this reaction occur? Very simple mechanism. होता क्या है कि you start from here, MECME OH methyl OH, and you reacted with H plus. The moment you reacted with H plus, one of the OH groups will pick up the H plus and it will turn itself into an oxonium ion. This oxonium ion will lose itself as water. ये बाहर निकल जाता है and we get this. Once we get this, this methyl will migrate over here. अब आप देखो कि इसमें एक बहुत इंटरेस्टिंग सी फीचर आती है कि ये 3 डिग्री कार्बोकैटायन है. 3 degree carbocation is usually created, but over here 3 degree carbocation rearranges. Why does a 3 degree carbocation rearrange? Remember that whenever a carbocation rearranges, it would do so if it is becoming more stable. Now, what are the features which make carbocation stable? It is hyperconjugation, resonance, aromaticity. So ये जो carbocation था, इसमें total of 6 hyperconjugative structures थे. यहाँ पे 3 hyperconjugative structures हैं, but you can see that there is resonance that can take place between the lone pair on oxygen atom and the positive charge on carbon, which results in the creation of this species. Once this is created, अब इसने एक H plus lose करना है and MEC double bond O C Me3 बना देगा. इसके कुछ important features हैं. So first feature ये है कि the RDS is the formation of first carbocation. Second feature ये है कि if there is a competition between the groups to migrate, so migratory aptitude क्या होगी? The migratory aptitude of H will be treated as more than pH, which will be treated more than Me. Okay, or pH with electron donating group will be more than pH with electron withdrawing group. Most of the cases में इन्हीं दो चीजों से आपका रिजल्ट निकल के आ जाएगा. So let's look at certain cases. So let's look at this particular reaction. मान लो कि हमने ये ले लिया PH C PH OH C Me Me OH. Now both the carbon atoms are different because they are attached to different groups. So where would H plus attack? There are two positions, but RDS is the formation of first carbocation. जो सबसे पहला carbocation बनता है prior to rearrangement is to be identified. सबसे stable carbocation यहाँ बनेगा, because over here the carbocation will be benzylic with respect to two phenyl groups. Over here it will be just having hyperconjugation. So carbocation will be formed over here. और भाई साहब MEMEOH, this Me will move over here, which will create PH, C, PH, Me, C, OH, positive, Me, and it will lose H plus to form PH, CPH, Me, double bond O. Okay. Let's look at another situation. अगर मैंने कुछ इस तरह से ले लिया मॉलिक्यूल को, एक कार्बन पे एक पीएच और एक मिथाइल ग्रुप है. We have one pH and one methyl group at each of the carbon atoms. Now, would there be any confusion in creating the first carbocation? No, both the positions are alike. You form the carbocation at any of these positions. So you will form the carbocation over here. So if you make this carbocation, now we need to identify what will happen next. We need to identify between methyl and phenyl which will migrate. So we'll use the logic of migratory aptitude. Phenyl's migration is more than that of methyl, so phenyl migration will take place and we will end up obtaining PH, CME, PH, COH with a positive charge, Me. It will lose H plus to become PH, CME, PH, C double bond O, Me. So देखो, you take either this compound, or this compound, you are getting the same product. ये हर केस में नहीं होगा, कुछ एक केसेस में जब आप ग्रुप्स को जंबल कर देते हो and same groups को ही if you so let's say you will observe this when you have A, C, B, OH competing versus A, C, B, A, OH. इन दोनों की प्रोडक्ट्स आपके सेम हो जाएंगे. Okay? So, not always, but be careful. Next, if I take into consideration any molecule in which the migrating group is chiral, okay? For example, मान लेते हैं मैंने ऐसा एक कंपाउंड ले लिया, PH, OH, and we have OH. There is a carbon. This carbon is connected to methyl. It's connected to another PH, H, and there is a methyl. Please do remember that the first carbocation will be formed over here. This will be lost. So I'm just directly drawing the carbocation. If I draw the carbocation, MEOH. Now this group will migrate. Okay, more substituted, more electron-rich group. This will migrate, and ये migration के बाद आप याद रखो, if the migrating group is chiral, then it migrates with the retention of configuration. सो आपके पास जो प्रोडक्ट बन के आएगा वो इस तरह का आएगा, Me डबल बॉन्ड O PH PH and this carbon Me PH H. So if its configuration is R, its configuration will persist as R. So migrating group if is chiral, then migration involves retention of configuration. Okay. Now, if I take into consideration कुछ एक यूनिक केस लेते हैं. अगर मैंने ये कंपाउंड लिया, सपोज इस तरह, 4-membered ring, and there is a pH over here, and there is OH. Another OH is here, and pH is here. अगर आप इसको ट्रीट करोगे H+ के साथ, तो ये याद रखो, you will be observing ring contraction. Okay, you will be observing ring contraction rather than compound to have the same ring size. This is not observed. ये मिलता नहीं है. ऐसा क्यों? So this is your compound. Once you create pH, once you create a carbocation by removing, so H+ add किया आपने, H2O बाहर निकल गया, so you have OH, you have pH. So this bond moves, so CC bond migration हो जाता है, and it creates a 3-membered ring. Why is this created? Because cyclopropyl methyl carbocation was found to be very, very stable as compared to any other conventional carbo. Even benzylic carbocation से भी ज़्यादा वो stable है. And now it will lose H+ to create yeah. Okay. The next reaction is homologation of ketones. Homologation of ketones का मतलब ये होता है कि if you have taken, actually homologation of ketones लिखा जाता है, but it can be utilized for an aldehyde as well. मतलब कि if you take a ketone, it will create a higher homolog. मतलब if you are taking acetone, it will create. If you are taking acetone, which is propanone, propanone will turn into butanone. Aldehyde will turn into a ketone. So this happens in presence of diazomethane, CH2N2. Now this reaction is very interesting because this reaction is not too much explored. You have to remember that diazomethane ना कुछ ये जो compound होता है वो इस तरह का रहता है. CH2N2 is in fact present like this. CH2- N triple bond N plus. इसके और भी resonating forms होते हैं, but if we take this into consideration, then what will happen is you can see that this is the nucleophilic center. This is the nucleophilic center. So acetone reacts with this nucleophilic center So CH2- attacks the carbon atom and you get CH3COOH O minus CH3 CH2 N triple bond N with a positive charge. Now this moves over here, this goes over here, and this goes out. 1, 2, 3. एक concerted mechanism होता है. Concerted मतलब a lot of steps, a lot of changes take place in a single step. So the negative charge from oxygen moves between oxygen and carbon, and the alkyl group which was present at that carbon moves to the CH2 group which is connected to N2. And nitrogen gets removed as N2 gas, which makes the process quite favorable because one of the products is going out as gaseous. The equilibrium is shifted in the forward direction. Okay? Is that clear? The same thing can be done with aldehyde, CH3, C double bond O, H plus CH2, N triple bond N with a positive charge. Sorry. Carbon has negative charge. This has positive. Attacks here. This comes over here, this moves over here, and this goes out, which creates CH3, C double bond O, CH3. Okay, so this reaction is known as the homologation of ketones. Let's move on to the next reaction, which is known as the Wolff rearrangement. याद रखिए, Wolff rearrangement is utilized within Arndt Oysterd synthesis. But हम Wolff rearrangement पे ध्यान देते हैं. What is Wolff rearrangement? Wolff rearrangement involves the conversion of a alpha diazoketone. जो diazoketone आप देख रहे हो, this is diazoketone into ketenes by applying heat in presence of silver oxide. Actually होता क्या है? So this reaction is pretty simple. Mechanism बहुत ही आसान है. So you take CH3, C double bond O, CH with a negative charge, N2 with a positive charge. ये negative यहाँ आता है. This comes over here and this goes out. So 1, 2, 3, and it creates CH3, CH, double bond C, double bond O plus N2. This is a ketene. This is a ketene. Okay? आप इसको इस तरह से भी समझ सकते हो. मतलब why it is told as that it is a migration to electron deficient carbon. तो आप इसको एक दूसरे दो स्टेप में you can break it down into two steps. You can form something like this: C double bond O, CH2 minus, N2 plus. If N2 leaves, then you will be getting CH3, C double bond O, CH2, something like this. Okay, you will get a carbene. And then this one comes over here, and then this moves over here. याद रखो कि carbene is electron deficient, so therefore this is studied under. Sorry, two नहीं होना चाहिए. Therefore this is studied under migration to electron deficient carbon. What are the applications? If you take a ketene and you treat it with, if you treat it with H2O, then this carbon will turn into COH. आपको ये मिल जाएगा CH3CH2COOH. If you treat it with an alcohol, you will be getting CH3CH2C double bond OR. You will get an ester. And if you treat it with a amine RNH2, then you will be getting CH3CH2C double bond ONHR. Okay, you will be getting a you will be getting an amide. Arndt-Eistet synthesis क्या होता है? Arndt-Eistet synthesis मैं यहाँ पर लिख देता हूँ. Arndt-Eistet synthesis बहुत सिंपल सी चीज है. You take RC double bond OH, you treat it with SOCl2, you will get RC double bond OCl, then it is being treated with CH2N2, आपको ये मिल जाता RC double bond OCHN2, and इसको आप हीट करते हो in presence of silver oxide and आपको मिलता है RCH double bond C double bond O. ये जो स्टेप है वुल्फ रीअरेंजमेंट का स्टेप है, and then it is being treated with H2O to get RCH2C double bond OH. So Arndt-Eistet synthesis में हम करते क्या है कि we take a carboxylic acid and we increase one CH2 group in that carboxylic acid through Wolff rearrangement. इसी चीज को हम बोलते हैं Arndt-Eistet synthesis. Okay, this is known as the Arndt-Eistet synthesis. Okay, the last thing for today is the benzylic acid rearrangement. आपने ये सुना भी होगा, कार्बोनिल कंपाउंड्स में बेंजिल टू बेंजिलिक एसिड रीअरेंजमेंट हम करते हैं. इट इज वन ऑफ दोज इंपॉर्टेंट रिएक्शंस जो कि ओलंपियाड्स के लिए काफी इंपॉर्टेंट है. एंड व्हाट हैपेंस इज इफ यू टेक अ 1,2 डाइकीटोन and treat it with a strong base, it undergoes rearrangement to yield a salt of alpha hydroxycarboxylic acid. And उसको आपने अगर H3 plus के साथ treat किया तो you will be getting a benzylic acid. What is the mechanism like? So you take the phenyl system, the diketone, aromatic diketone, and it reacts with OH minus. OH minus attacks one of the carbon atoms, and this goes like, becomes like this, and it turns into O minus OH, okay, something like this happens. and इसके बाद क्या होगा? O minus से जो negative charge है, that will move towards the carbon, and this phenyl will migrate all the way over here. So 1, 2, 3 कुछ इस तरह की सिस्टम जनरेट हो जाती है. phenyl O minus, there is a phenyl unit, C double bond OH. This will undergo an intramolecular proton transfer, H plus transfer, and it will create O minus, which will eventually react with H3O plus to give the benzylic acid. Okay. इसमें आप देख रहे हो कि इलेक्ट्रॉन डेफिशिएंट कार्बन पे माइग्रेशन हो रहा है. दिस कार्बन मस्ट हैव बीन इलेक्ट्रॉन डेफिशिएंट, तभी वहां माइग्रेशन हो रहा है. ओके, सो ये हो गए आपके 4 इंपॉर्टेंट रिएक्शंस. प्लीज रिमेंबर दैट दीज रिएक्शंस आर वेरी वाइटल फॉर एटलीस्ट फर्स्ट 3 तो आपको जानने होंगे अच्छे से फॉर JEE. The fourth one is more important for chemistry Olympiads. Okay. So with that, I take leave for today. Please try to work out examples on these. Try to rewrite the mechanism, and I'll see you in the next session. And next session में हम लोग कुछ और interesting चीजें discuss करेंगे. So bye bye and have a lovely time, guys. See ya.